looked at so far has dealt with speeds, velocities, accelerations, displacements, times. They've all been basically in straight lines or two directions. So today what we're going to look at is the vector part of this, which deals with going in different directions. So to begin with, the example I like to begin with, just to make it make sense to you. If you were to tell somebody that was standing out on the front steps of the school here and say, they asked you, they pull up and they say, okay, well, how do I get to the fire hall? All right? So to make it as easy as possible, all right, you're going to say, go 2 blocks to the north towards the hospital, hit the highway, hang a right, go 3 blocks to the, what we refer to as the east, you'd be at the fire hall. You'd be on your right, correct? All right, so now let's say someone that wants to go in the straightest line possible from here to the elementary school, not using roads. Let's say they're flying a model airplane or a helicopter, and they're going to go from here to there, and you're asked to tell them specifically, how do you go from the front of the high school directly to the fire hall? Okay? So you need to have very specific directions. We're not going to follow roads. We're going to go in a straight line. So let's use the straight line part of this to tell us how we can figure out how to explain to somebody to fly a helicopter from here to the fire hall. Okay? So to draw it out, I'm going to use 2 vectors to draw it out. I'm going to use the north vector, the one that's going to represent going to 2 blocks. And then I'm going to represent the east vector, which is going to go to the right. Now, rule number 1 when it comes to vectors, draw tip to tail. So that means that when you draw your first vector, you're going to have a tail and you're going to have a tip. The arrowheads represent the tip. The straight line at the bottom represents the tail. The second vector is going to be drawn from the tip of the first one. We're going to do that at all times. There is a way in which we do subtraction of vectors, in which you go tail to tail, but we never do it. To me, it's easiest to do it consistently the same all the time. Now, when you're just drawing 2 straight line vectors in which you're going to have a right angle, life is easy. But we all know that that's not going to be the case when we are doing these things. But in the example I'm showing you, that's what's going to happen. So I'm going to draw, first of all, a arrow to the north that represents us going 2 blocks that way. So I'll even use 2 blocks. Okay? Now, the book is also going to say, well, if you draw these out using a ruler and a protractor and draw it by scale, you can get your answer as well. And that's correct. But because we are in grade 11 and we've all done sine laws, cos laws, and right triangle trig, the easiest way to approach these questions is to use trigonometry. Okay? So then, I get to the hospital, I hit the highway, and I need to go 3 blocks to the east. So that's where my next arrow begins, right here. And I go this way. And that is 3 blocks. And we haven't done as much as we should have in terms of labeling our directions, but now we must label our directions. It's going to be imperative. So now you're saying, okay, well, 2 blocks to the north, 3 blocks to the east. That's awesome, but I want to fly my helicopter in a straight line, not following the roads. The hypotenuse. So I'm going to use this triangle I have created. Notice I'm still starting right in front of the school here. This is the school. Here's my fire hall up here, right? So you have to explain, how do I go from there to there? So the first thing I do is I use Pythagoras' theorem. 2 squared, 4. 3 squared, 9. Square root of 13. How much in your calculator, please? 3.606 blocks, right? Yep.
So there's
Okay.
going to be a lot of like a squared plus b squared.
Yeah.
C
Yes.
Nice.
Okay?
Oh,
So now, that still doesn't help because I can go 3.6 blocks that way
Northeast.
and I'm going to end up down at Goose Lake. Right? So I need to be specific as to the direction. Rule number 2. The angle you find is always where you have begun your journey. Now think about it. I am starting right here. I am going to explain to somebody the actual direction in which I've got to go. So that should be from right here. You go so far north, and then this many degrees to the east. So now we use right angled trig. Where is this in relation to this angle?
Opposite.
And this?
Adjacent.
Adjacent. So which trig function am I working with?
Tan.
So the tangent of my angle is equal to 3 over 2. So again, use your calculators. Second function tan. Again, because you're finding an angle, use second function. Angle's a half. 1 over 1.5. Go ahead.
56.31.
So you say that you tell somebody that's going to fly their remote control helicopter from the front steps to the fire hall, hey, you got to go 3.606 blocks north, 56.31 degrees to the east. Done. Done. That's it. That's all there is to it. Any questions about it?
Well, last year we just did like 56.31 degrees northeast, or northeast 56 degrees. Is that
In what class?
in
Science.
Science. Okay.
the physics section of it?
Right. You have to state it in the proper rectangle, which you should have learned that in grade 10 science. The proper way of doing it is north, telling the intended direction, and then I have a choice. Do I go east or do I go west from that point? Well, I got to go 56.31 degrees to the east of that. Okay? So you must write that in the correct way of doing it. Now, you could, however, use the complementary part of the angle where you say east, 33.69 degrees to the north. Also okay. Depending on how you draw this triangle, right? What if I told somebody, I wouldn't because it would get all mixed up. I went because it was to the north and the east made sense, but I could go to the east and then to the north, right? But we all know that you'd be zigzagging to get there according to our roads. The most straight way by road is to go down Hospital Street, down the highway, and you're there. But realistically, I could go this way first, this way second, in which I would get that angle, and it would be the complement of this angle. Still okay. The beauty of it, you can do whatever triangle you want, as long as you draw the tip to tail method. Meaning the second vector has to be in the starting at the tip of the first vector. Okay? Now, where it gets semi-complicated for you is, well, what happens if we have 3 directions? Let's say I was going from here. I want to go as straight line as possible. So I was going to go from here to, let's say, the motor inn. So I'm going to go 2 blocks to the north. I'm going to go take the highway, right? So I'm going to go maybe 4 blocks along the highway, and then I'm going to go another block to the north again, and I'm going to end up where I want to, at the motor inn. Fair enough? Well, let's see how that looks according to this, and let's see how we can draw it. And then what's going to happen. All right, so using the same strategy I just used. Don't write this one out, okay? I'm just showing this as an example. So I'm going to go 2 blocks to the north again. This time I'm going to go 4 blocks to the east, because it's past the fire hall, right? Block past the fire hall, east.
1 block more.
And I gotta go back again 1 block to the north one more time, right? All right. So again, somebody comes and says, well, I want to fly a drone from the front of the high school directly to the motor in. You have to tell them, well, you got to go like this, up to here, and you got to go in a certain direction. So we now are tasked with, how do I find this? Well, here's the thing. If you looked at it like this, I could essentially create 2 triangles, couldn't I? I don't know how far this is. I do know the length of this side, but I don't really know an angle either. So it makes it a little more difficult to do that. I could extend this down. I could create that, and then I could find that, which then would, or I know this, then I could find this. It's a little more complicated, right? Correct?
Yes.
So it's not as simple as it looks, is it? How do I find out that? Well, what I want you to do and what I want you to learn is a simple method in which we look at all of our horizontal and our vertical directions and we'll net them. Meaning we're going to add them up so that we can come up with one final triangle that looks exactly like this blue triangle right here. Well, what do we actually know? If I were to draw this out, what's the distance from here to here?
2 blocks.
What is it?
2 blocks, sorry.
2 blocks.
So really, yeah, that makes sense.
Right? And then what's the distance from here to here?
4
So 4 blocks, bless you. So essentially then, I just have to find out what that hypotenuse is there, right? And what this angle is, and I'm done. Make sense? All right? I've never done this before. This is the first time I've ever done it, and it's the first time it actually probably makes more sense than anything I've ever taught. That's the way it looks. So what I would actually have told you to do before I come up with this is I would say this, okay, make a little table for yourself. Why? Like you. Pretty wide, you can stay. All right. So now I have X and Y. X represents all my horizontal distances or displacements. Y is going to represent all of my vertical. Okay? So according to my original information, what was the horizontal? 4 which way?
Easy.
4 blocks east, right? So I want to write that in there as 4 blocks, and that's east. Now, do I have any other horizontal?
No.
No. What do I have for vertical?
3 blocks north.
No, by individuals. Let's look at the individual
2
vectors.
blocks north,
2 blocks to the north, right?
and another 1 block.
Another 1 block to the north. So that would essentially give me 4 blocks to the east,
3 blocks to the north.
3 blocks to the north, which makes perfect sense, right? We just proved this. Correct?
B squared. B squared.
Oh, that should be north right there. Should be north. So then I would actually tell you, at this point, you would draw your triangle. Well, I already got my triangle. It was this. Okay? So now I go 2 squared, 4, plus 16, 20. Square root of 20 is?
No.
4.6.
Square root of 20, please.
2.
4, 7?
472.
472. Perfect. So now that I've got the distance, what's the last thing I need to find then?
Angle.
The angle. So I got to find this angle. Where is that in relation to this? Opposite. Where is this? Adjacent. So what am I talking about again? Tangent again. So tan of 3 over 4.
4.
36.8. Do you want rounded to 3 or 2?
3 would be great.
870.
Perfect. So you're telling somebody to fly a drone from the front of the school to the motor inn. You say, hey, you got to go 4.472 blocks east, 36.87 degrees to the north. Yeah? Hey, how's that look?
Pretty simple.
Pretty simple right now, right?
Yeah.
Okay. It doesn't get much more complicated than that. Once you have 3 vectors, that's it. That's the maximum you're going to do. Now, where it gets complicated is if they go in angled directions. So I'm going to show you an example of that now. As long as we have this bit.
Right. 4, is that the total distance to the motor in? Wouldn't it be 5 blocks?
Yeah.
Is that 3, 4, 5?
3, 4, 5. Now, what did I say?
I think you just did it with the 2 instead of
Oh, I did 3. Yeah, I did. You're right. Thanks, Alexander. Oh, I should have said 3 blocks.
3, 4, 5, Sean?
Yeah.
5
5 blocks, that's right. Yeah, I used the 2 instead. I said 2 squared, which is 4. Instead of 3 squared. The whole side is 3. Okay? So that's absolutely right. Okay, how are we making up? Okay? Semi? All right. So this is all that we actually add on to what you've already done. We still maintain with the 5 equations. Stays the same. So and that's the good part. There's nothing new. The only thing is now we're adjusting our directions a little bit more than what we did. Okay, so have a look now.
This stuff looks a lot more better.
Let's look at page 93. Okay. So page 93, we're going to look at the first practice question. A police cruiser chasing a speeding motorist traveled 60 kilometers to the south, 35 kilometers to the northeast, and finally 50 kilometers to the west. It says calculate the total displacement of the cruiser. All right, so I need the total displacement. So drawing out arrows right now. 60 kilometers to the south.
Does it have to be square brackets? Is that like
Yes.
change?
Okay? Then where he goes where?
Southeast, or northeast.
Northeast,
35.
35 kilometers to the northeast.
What type of an angle? Or we just
Okay. Now, I have explained this to you already, in fact. What does northeast tell us about the angle?
45 degrees.
Has to be 45, right? If there's no degrees in between the actual directions, right, then that means it's exactly halfway in between, which means that it would be 45-degree angle. Okay? So then it goes 50 kilometers to the west at that point too, right, which goes somewhere over here. So far, so good. So to find the displacement, by definition, what is displacement?
The initial velocity, or
Point at which
Right.
Like from the 60 kilometers to that point to that point.
we start the end.
Okay, so from the
Very
tail
short
of your
vector.
first vector, right, to the tip of your last vector, does that make sense? So basically, it's from your initial spot where you started to the spot where you finished. So I want to find then, right here, that is my displacement. That is my displacement. Now, again, I'm going to explain this to you. That's going to seem, right now, more complicated than it needs to. But the reason I'm explaining it, because when you get into a little bit more complicated questions, then this will be just the same as what you've already done. All right? The easy way to do this question, without any, without redrawing or anything like that, or any, I know this is 45 degrees right here,
Don't
right?
we know all the angles?
We know these ones right here are 45. We know those. We know this information from this triangle right here. Right? So therefore I can find that side and that side. Because we also know that they're equal. Because we have an equilateral triangle, right? Okay? And we have the hypotenuse measurement. Alright, but I'm going to show you something that how I would do this a little bit different than what I've got shown right here. Okay? And again, it's going to seem like more work to you right now. It's going to seem like more work because I can simply use that one triangle and solve that question quickly. And we will. I'll come back to it. But here's what I'd like to see you do. Just like I did on the last question, I'd like to see you set up a little bit of a chart. Just like this. X, Y. X represents the horizontal distances. The horizontal distances will always be your east-west. The vertical will be your north-south. Simple, right? Okay. So, looking at the first,
Oh yeah, what about northeast?
well, I'm getting there. Just relax here. Okay. So looking at the actual question, the first vector was 60 kilometers to the south. So where do I put that on that chart? I put that under my Y, right? So I'm going to put 60 kilometers to the south right here.
Yeah, that's why it's under Y.
It's very vertical.
Okay.
Alright, yeah.
All right. So there's my first vertical one. Now, the northeast one. The northeast looks like this, right? So there's two components to it. I haven't talked about that. Vectors can have one component or two components. If they're not on your north, east, south, or west, they will always have two components to them. So we need to find out what each of those components is. So this is what I was alluding to just a second ago. I know this is 45 degrees right here. This is 45 right here. And it was 35 kilometers, correct? So I need to find out how much north that is and how much east it is. Okay? So, here's my x right here. Right? Where is that in relation to 45?
Opposite.
Opposite. Where's 35 in relation? Hypotenuse. Which trig function am I talking about? Sine. So let's go the sine of 45 equals x over 35. How do I solve for x? Times it. That's right. 35 times sine 45. What do I get?
24.749.
24.749. Okay. Now, what direction is that? Sorry?
East.
That's east. Right? So where does that go right here? Right there. So I have that. What is the measure of that north one?
0.74.
24.74. You got that pretty quick. How come? A little louder, Amron.
You told us that they were going to do the same anyways because it was an equilateral triangle.
That's right.
Angles are the same.
That's right. Good. You were listening. Good. So 24.749. That direction is what? North. So that has to go here, doesn't it? Okay, so that takes care of that vector. I got both my components.
749.
Oh yeah, I'm gonna do that every year. Good, right? Okay. So now, you gotta look back at the question because there was a third vector, wasn't there? What direction was the third vector?
West.
50 to the what?
West.
West. Okay. All right. Now I want to find the net components. Do you know what net means?
I'm not doing the altitude, like, you got the options, so we'll be able to report.
Okay. So what I'm trying to do is I'm trying to find out all of the positives and negatives. I add them together to find out where I'm actually at with this. Okay? So, starting with this, I have an east here and a west here. 50 west, 24 east. Now, you can, if it makes sense to you, switch that first one to a negative, or you can just use your mind and say, is it going to go west or is it going to go east because of the numbers I've got there? Which is larger? West. So take 50, subtract 24.749.
25.251 west.
25.251, and we know that that's going to be west, don't we? And what about the top one then?
35.251 south.
35.251 to the south. Okay. I'm going to draw this out now. I'm going to draw it out, okay? Again, doesn't matter if I do west first or south first, but it's going to look like this. The one thing that I have just done here is I have allowed myself to only use right triangle trig. Far easier than using sine and cos, right? Or sorry, sine law and cos law, right? So now, I've used this whole question, all I've done is right angle trig. You can't do that, we need to move on with life. Okay? Here, 35.251 south. What's over here? 25.251 to the west. Calculate my displacement. What am I using? Pythagoras' theorem again. So again, it's right angle trig. It's easy for you. You've been doing enough of it. So what do I get?
43.362.
These are all kilometers, right? Should be writing my units in. I haven't been. All right. And I need my direction.
$35.6, I think. 1.5 southwest.
155.474.
Okay.
35.
Well, you guys, if you were talking it out, you'd have a heck of an argument that you're both right.
Which one?
So the thing is, it depends on what, right? You've got the complement of each other, right?
Yeah.
Where is this in relation to that?
Opposite.
Where is this?
Adjacent.
So it has to be second function tan, 25.251 divided by 35.251.
That's the idea.
But you can catch the other formula too. Like the one where you like.
You could use sine and cos, yes. But if I've done Pythagoras' theorem wrong, then I'm going to get the angle wrong. So using the values that I should know, yeah, but you could check your answer using that too. No problem. If you like that, go ahead. What is the correct answer? Which one of you guys has it right?
I did the 25 divided by the 35.
They're both right. They're just
Okay, well, which one is
two slides.
for this?
35.6.
Okay, so what is the direction then? How do I write that out?
West 35.
So,
First arrow I drew was which direction?
So,
South, and then I
what
went
angle
west
you're
of
going
there.
for?
This one, then where I started. So it's south, 35.615
615.
degrees to the west. We all following what I did there?
Yes.
Yeah? Are we okay?
Yeah.
Okay, I'm going to show you something. Let's have a look-see. What did I actually draw right here?
The same triangle.
Look at that triangle right there. That's what I ended up drawing to get the final answer. Because right here, using this triangle, was the components of that guy. So this is 24.749. This is 24.749. I would get this one by taking 60, subtract that, and this one, 50, subtract that. So I did it all that way. But what I did was make it look a lot neater by finding the components of each of them. Okay, so far? Again, I stuck the right angle trig for this. Okay? Questions? No? Okay. Let's look at the drawing for the second one. Let's do that right now.
So B.
Express bus travels directly from A to B. A local bus also links these two towns, but it goes 30 kilometers west from A to C, then 30 kilometers south to D, and finally 12 kilometers west to E, and 30 kilometers northeast to B. What is the shortest distance from A to B? Okay, so let's just try sketching based on that information. So what's the first direction that he goes from A to C is what?
West 30 kilometers.
A to C. Oh, west 30? Yeah,
30.
great, thank you. So west 30, that's 30 west, right?
30 south is next.
And then he goes 30 to the south.
Another
Again, I should put
12,
my ears in. And then where?
another 12 west.
Another 12 to the west.
And then 30 northeast.
And then 30 to the northeast.
Yeah.
That's what it looks like. Looks complicated, doesn't it? Looks a little complicated because now they want the fastest, shortest distance, sorry, not the fastest route, but the shortest distance, which should be the fastest route, but shortest distance from here to right there. Now, I can't make any presumptions here because the drawing is not to scale. So I have to figure out then, based on, I don't know how high this goes, I don't know how short this looks like, I just kind of sketched it, right? So now I'm kind of having to make some evaluations on this as to how do I calculate then what that distance is. All right, now I kind of have one solid looking triangle there that I can see, right? In which I know that this is 45 degrees right here. So I could probably get that there as well. Subtract it to get this, but then that still doesn't really help because I don't know how far that goes up. So this is why I said the best way to do this question is set up a little chart. And then we'll find out what the net is, and that will tell me what this triangle looks like based on that information. Brock, go ahead.
Can you not figure out every angle that like there is in the red? Because
You
you're
could,
going south to straight west, that's obviously 90 degrees.
yes.
And then from 40, like where you have the 45 written, northeast up to like the middle of the south or whatever, that's
Mhm.
gotta be 45 too.
Mhm.
So that'll make 180. And then from the top, 30 west down straight south, that's gotta be 90.
And then alternating interior angles.
Yeah, so then the next one down is gotta be 45. So you can find every angle in there, can't you?
But-
Yeah, but
Then how does because it would
You are excellent right up to here. You're great.
Yeah.
It's this line. That does
Wouldn't
not
that be
mean
a-
that that's going to be 45 right there.
that's not a triangle.
Because that's not, like, it looks like this, I'm drawing this straight on,
Yeah.
but it could be like over to here, or it could be down to here.
Yeah,
I can't tell.
But
So
wouldn't
you've
it-
got it, you've got all that you said right now is 100% correct. We just struggle to know whether or not this would go straight back to that or not. And that's what your assumption is.
Yeah.
That it would go straight back, which means that would be 45 because it would be interior alternate, like I said. But we don't know that.
But even
Okay?
if it doesn't go straight back, those two lines are parallel, and that would be like a transversal, so it would just
Yeah,
be
but it doesn't,
corresponding, no?
Austin. I am saying that this does not go in a straight line.
Yeah, but it would still be corresponding whether it's
Austin, it could
straight,
be up like this, it could be down like this.
but it would still correspond.
No, because you would be going, no.
No.
Just
Austin, this line could go up to here, and then it has to go like this on an angle. That's no longer a transversal.
We don't know.
You don't know it. Like Austin, you're saying that this line is a straight line right to here. That's what you're saying. And it's not. It's not necessarily. Okay. So I just finished explaining to Brock. This does not necessarily go in a straight line. It could go up to here and then angle this way. It could go down to here and angle up that way. We don't know. So we can't, that's what I'm trying to tell you right now, is that that's not the case. So I can't do it that way. Emery, go ahead.
I would play in my calculator.
No, wait till we're done this question because you're going to get lost.
It's the same as that one, no?
No. Okay, so that's why I go back to this. Again, I now have 4 vectors. 4 vectors. So I've got to just write the components of all the vectors out. Okay, so the first one was 30 to the west. That goes right here. The second one was 30 to the south.
And then 12 what's at the end.
So far, so good. Now I have that northeast one. So what I'm going to do is draw it up here. Calculate for me what the north and the east components are of those.
21.213.
Yeah.
So,
Okay, good enough.
Yep.
So what directions are those? That one's east and this one is north. So we put that on there. 21.213 to the east. 21.213 to the north. So now my goal again, like I said before, was to find out what that triangle is. I need the parts of that triangle in order to solve this question. So I'm going to do that by calculating my net here and then redrawing it. Okay, so I've got 30 to the west. That makes 42 to the west, and 42 subtract 21.213 is what?
20.787. Just 20, not 28.
Sorry, you're right. 20.787 kilometers, and that is west, correct? Okay, 30 subtract here is
8.787.
and that will be south, right? Are we following? Okay. So now, south, west, and that is right here, which is that right there. So you got to calculate this. Rock. So calculate what that displacement is.
This is in kilometers, right?
Yeah. Okay, and let's calculate our direction.
So west 24 degrees south. No 24. Where did you get 24?
Okay.
And I just
Right. Okay, but I want you to look at the board for a second. What's the first direction I went from right here?
so
So So if that's the case, then what's the actual answer from the board?
67.
Did both of them have to equal 90?
Yes.
Yeah.
How?
So what is it?
6. 66?
Yes.
North is, or, yeah, north, or south.
South 66 to the west would be right. Okay, what is the actual answer? With the right decimals?
67.
Oh,
What, what?
05, or 085.
Zero.
085.
Thank you. And that would be west. Okay? So the reason I show you this chart is when you have multiple vectors. If you can draw these out and you don't need the chart, that's okay too. But what the chart does is it makes sure that you are only using right triangle trig for all the questions. Okay, you don't have to use any of the law of sines or cosines. Now, we're not into the law of sines or cosines yet, but there are questions coming that we will do that are with the law of sines and cosines. Okay, how are we with this so far? Because I'm going to give you something that's going to, again, elevate it a little bit. Yeah, Rex, go ahead.
So if you had a question that said, yeah, you went like 30 degrees north, or 30 kilometers northeast, and then 40 kilometers west, you'd have to use your cosines and pick your sine.
Yeah, yes, okay, yeah, sort of. So if you were going, like you'd have this and you'd have this, right?
Yeah.
Yeah, you could use, because you don't know, it might be there, it could be further, it could be way over here and up. But yeah, that's a good point, Rex. This is a type of question here, what you're going to see is if you had two of these, this obviously isn't a right triangle here. Okay? So you could use your law of sines or your law of cosines to help you solve this at that point. And we are going to see lots of questions like this as well. But I could still do it using only right angle trig by finding the components of this guy first, subtracting it from the components of that, and it would still be just a right angle, which would give me a triangle that would look something like that.
But you
But it
could,
would still get me this line.
you could just use like sine, cosine, tan,
Yes.
figure out angles.
No, because it's not right angle. You'd have to draw your components for it. So that means if I would take this individually like this, and I would find out what this and this was, and then I would subtract it from that there on my X and Y chart. Okay? So yes, there are circumstances we're going to get into, and probably sooner than later. In fact, the next section here. Okay, now, one of the things I said to you earlier is I don't draw tail to tail. Now, if you're subtracting vectors, okay, you can draw tail to tail, but I don't encourage it because of the angles you make errors. So instead, I'm going to use an example to explain myself, and then I'll show you how it looks. Take a look at page 97. The first part says, determine what A plus B is. So they want you to measure it and determine it. I'm just going to show you how I draw it. I draw A first, which looks something like that, right? And then to draw B, I go to the tip of this guy and draw B, which would be in that direction right there. Now, we did a number of questions in applied where we drew vectors out already. We've done this. All right? And my suggestion is to always put your little grid in here when you're drawing them if they're giving you degrees and angles. All right? So that's how I would draw A and B. The second one says C and D, but I want to take D and I want to subtract C. So here's your first tidbit of advice coming from me, having done this for so many years. They say draw them tail to tail and then find out, don't do that. Draw D first. So D in this case is a little arrow going this way, right? That's D. Is everybody following me? I need you to watch this book here, page 97. So that's D. That's D, right? It wants you to subtract C. Draw C in its opposite direction. So right now it's going which way? It's going north. So I would draw it to the south, and this is the correct answer for you. This would be D subtract C.
But then in that case you would go.
And you'd get that angle. Sorry?
In that case you would go tail to tail.
Nope. Yes, sorry. You're right. Tip to tail, yeah. Okay? That keeps you consistent. That means then you never have to change whatever you're doing. You're constantly going tip to tail. So even if you subtract them. And what I equate this to is, if I ask you to take 5 subtract 3. Of course we can do that. All right? Some of you need a calculator, but most you can do it. Right? So I got 5 subtract 3. I can write it that way, or I can write it as 5 add negative 3.
That
Means the same thing, right? Means the same thing. 5 add negative 3 and 5. Hey, Brock. Commentary, please. 5 subtract 3 or 5 add negative 3. Means the same thing. You're still going left on your number line 3 from 5, right? Well, how I equate this is to this. I'm basically adding the negative of that vector. And when you change a vector and put a negative in front, all you're doing is changing its sign. So a negative east is west. A negative south is north. Okay, that's all I'm doing is I'm just changing it by adding a negative in. So this was actually D plus negative C. C was north, negative C is actually the south direction. So that's why I do it that way. Okay, now let's look at that second question. Here's where our money comes in here. A plane's velocity changes from 200 kilometers an hour north to 300 kilometers an hour north, 30 degrees to the west. Find the change in velocity. All right. First thing I do, now get used to this. Writing out an equation in which its only purpose is not to solve the question, but to tell you how to draw your vectors. That's the only purpose of the equation right now. So what is change in velocity? How do I find change in velocity? V2 subtract V1. V2 subtract V1. Okay? So the only purpose of this right now is to tell you how to draw your vectors. So look at the question then. It says, so this goes right to the question you asked 5 minutes ago, Rex. What is my V2 vector in this question? 300 kilometers an hour, north, 30 degrees west. That's my V2. I'm going to draw it first. So I would start like this, put my little grid down, north, up, 30 degrees to the west. That's 30 degrees right here. And this is 300 kilometers per hour. There's my V2 vector. My V1 vector is 200 kilometers an hour to the north. But this equation says I want the negative of that. So I want to put it to the south. So I draw it down like this. In fact, it's probably, I don't know, is it 200?
Yeah.
Yeah, so it'll be right there.
So the way you do it is pretty much just opposite of what the book tells you.
Okay,
But the length of that line would probably depend on how long
Now.
you go, right?
now, this is what we don't know. So this is why we have to, when we're doing these, we have to have an idea as to what it looks like. That's what I'm looking for right there. So I have a triangle that looks like this. I want to find that guy right there. I know this is 30 degrees right here. I know this is 300. Oh, sorry, 200. And this is 300. So now I have to solve to find change in velocity, which is that guy, and I need to know that angle. All right? Putting your math skills to work. What's the first thing that I know inside that triangle? 30 degrees. So this is 30 right here. Okay? Now I'm no longer using right triangle trig. So what am I using? Can I use the law of sines or the law of cosines here? Do I have an angle and a side across?
No.
Nope, I don't. So I can't use sine. So what do I have to use? Cosine. Okay? So those of you that are comfortable with it, by all means. Right? This would be equal to, my change in velocity would be equal to the square root of 200 squared plus 300 squared minus 2 times 200 times 300 times the cos of 30. And that would give me my change in velocity vector. And then I would use the law of sines to find that one in the middle. So how many of us right now would far sooner use right triangle trig than the law of cosines? Okay. So I'm going to show you how we go about that too then. All right? Yeah.
Like, I'm not trying to make it difficult here, but 300 and 200, that was your speed, right? So the length of the line is not the speed, right? It would depend on how long you go for that
You
speed.
can draw it whatever you want.
But they're calling it as an hour. It's like, 300 kilometers an hour or 300 kilometers for 200
I'm not looking for my displacement right now. I'm looking for my change in velocity. So 300 kilometers an hour and 200 kilometers an hour are velocities. Okay, let me put it to you this way. All right? You're going, you start at 0, you start from rest, right? And in 10 seconds, you're going 10 meters per second. So what's your change in velocity?
10 meters. Or 10 meters.
You went from 0 to 10.
Yeah.
So what's your velocity? Change in velocity. 10 meters per second. 10 subtract 0. Right? Yeah?
Yeah.
I'm doing the same thing. I'm going in different directions now, so I have to draw them based on that. I understand what you're saying. You're saying this would be, you think you should have displacements here and here.
Yeah.
But no, I can do this with velocities as well. Okay? All right. So, for those of you that would prefer to do the right angle trig, is I would draw my components again. And then I can solve using just a right triangle. So to do that, I draw this component, which is 300. And I guess this would be 60 degrees here, right? Yeah, you know what? Let me do that different, okay? This is what they gave us. Okay, so that's 30 degrees. This is 300. Correct? So do I have enough information to find out how far north it goes and how far east it goes? Yeah, I have a right triangle, correct? All components, every time you find your components, they're all right triangle trig. Because you're going in two directions. Okay, so sine of 30 is a half times 300. That makes this 150 right here. 150 kilometers per hour. Okay? Now take the cos of 30 times 300. I need help.
250 hours.
Okay. So I've got that. I also have the negative of my V1, which was what? 200 in which direction?
North.
That's the positive, right? But what's the negative of it?
South.
So that's 200 kilometers an hour to the south. Okay? Using my little chart right now, I have 200 south. I have 259.808 to the north. Oh, I got this wrong. Sorry. $200 south, 259.808 to the north, and 150 to the east. Okay, so far so good. So I've entered in all the components of my two vectors. So north-south net is what?
59.2
North? 59.808 north. 150 to the east.
Yeah.
So far so good. Now I draw a right triangle. $59.808. No, sorry, this should have been, sorry guys. This should have been west, right? It was given to me as west in the question.
What about the 300? What do you do with that? Just leave it?
I broke it into its components.
Oh, those are the
Right?
ones that
This plus this gives me the 300.
Okay.
So I broke it down.
Yeah.
Okay, that's a good question. So then this is 150 degrees to the west. Oh, it's not. It's east the way I drew it. Sorry, guys. Run out of steam here. Oh,
It's fine. It's the end of the day.
okay. So I've got
That is quite impressive.
north 59.808, north 150 to the west, and let's get this and this.
Oh, 161.
What is it? 161.484.
161.484.
That's kilometers per hour. Okay? And what's my angle right here? Second function tan, 150 divided by 59.08.
68.260.
Okay? 161.484 kilometers per hour. 68.262. All using right angle trig. You follow that part. Let's go back a page. Calculate this for me. Square root 300 squared plus 200 squared minus 2 times 200 times 300 times the cosine of 30.
Oh, you get the same thing. That's nice.
What is it?
161.484. The other way is definitely longer than that.
Okay, but here's the thing.
Yeah, because I can't get my angle.
Here's the thing. So now I've got to get this guy right here.
Since you already have the side, it's fine.
Right. So I've got sine of that angle over the side opposite is 200. Sine 30 over 161.484.
Let's do right angle trade.
Okay? So 200 times sine 30 divided by 161.484 and take the second function sine, what do you get? Girls, are you doing this or not?
I got
An
something
error
set
one.
before we can get our calculators turned.
Well, I still want you engaged, okay? You're more than welcome to speak up. What do we get? Because there should be a
38.262.
38.262.
That's what I got.
Was that what we got on the last page for the angle?
No, 68.
Oh, we're just
Oh,
finding the other.
But your angle's not right at the ground, it's up a little bit, right? So I think that's got something to do with it.
All right. 38.262, 68.262. What's the problem here? I actually found that whole angle right here. So if I'm talking about north, I have to add those two together. That gives me 68.262. If you like the law of cosines and the law of sines, the question's a lot faster.
When you did like the change of the velocity, like the long thing, I keep getting 333.
Okay, you tell me where you're at. Right here?
Yeah, like I did 200, or like square root 200 squared plus 300 squared, take
Yeah.
root 2 times 200
Yeah.
times 300, cos 30,
Yeah.
bracket, and I get 350.
Second bracket.
I've only been,
You should have two brackets on that.
so it's cos first, I hit, nope.
Now just pull it up and it's make sure there's two brackets on the end. There is one other reason why that this probably isn't working.
Plus 300 squared.
Okay, how many like the right angle method better?
Oh,
couple.
yes, sir.
It takes a while.
Okay, so here's what here's how I decide myself personally between the two. If I only have two vectors, I use law of sines and cosines. If I have any more than two vectors, I use the right angle trig method.
Right angle is just more like
Takes too
precise.
long.
Do you use cos for this?
I would use law of cosines. Okay? Because it is quicker. All right? I do understand where my angle is at though. You have to. Okay? But if I have more than two vectors, then this question becomes a lot more difficult to use the law of sines and cosines. Okay, did you figure it out?
Yeah.
Okay. I think I know.
You can't like go left.
You're in radians instead of degrees. There you go. You got it right.
Thank
Okay.
you.
All right. Comments or questions about those two? Okay, I need to hammer this into you because I will tell you this every day until the test, and still at least one of you is going to do this the wrong way. This equation right here, I do not stick numbers into that equation now. Don't stick numbers into it. It is a guide to tell you how to draw your vectors. That's what the equation does. I did not put 300 in here and 200 in there. I didn't do that. I drew them based on what the equation told me. The only thing that it's telling you is I want to use a negative 200 north instead of putting it in there. Okay, now somebody's going to do it. I guarantee it. It happens every year.
So for
No
that
matter
one,
how many times I tell you.
you drew your V2 first or whatever?
I draw my V2 first because the equation tells me to.
Oh, and that's why we're getting.
Yes.
And then you did an opposite V1.
And then I did an opposite for the V1 because it's a negative. That's right.
Yeah, I don't think so.
Okay? That's why. This is a guide to tell you how to draw. Now when we get into airplanes, all right, in wind direction, which is what we're going, that's where we lead to. We got a lot of questions on that. It again, it's based on the equation. The equation will tell you how to draw it. That's what it's for. It's not to put numbers in and solve. It tell you how to draw it. Okay? So there were just the 3 questions on 93. You can finish them both off. And questions 2, 3, and 4 on 97. All based on this. Okay? And that's today.
Did you read it? Second example.
Oh, man.
The one where he went to the border and